Alright, so this says find the measure of the reference angle. So we are now in the calculator portion of the test. You are allowed to use a calculator for anything here. So it says find the measure of the reference angle. Remember, reference angles have to be between 0 and 90. So the first thing you want to do, since this is a really big angle, you want to subtract it from 360. You wind up getting 278. 278 is in the fourth quadrant. Yes, it looks like it's in the third, but remember, it's bigger than 270. So it's in the fourth quadrant. The fourth quadrant rule is to do 360 minus the angle. Well, if I do 360 minus 278, I wind up getting 82 degrees. If you got 98 degrees, remember 98 is not between 0 and 90. So that would be incorrect. Please make sure that all of your angles are between 0 and 90. Alright, number 2, negative 533. You're just going to add 360 until you get a positive number. You wind up getting 187. Now 187 is not in the first, it's not in the second, even though it looks like it might be. It's actually in the third quadrant. The third quadrant rule is to take your angle and subtract it from 180. So you should have gotten 7 degrees. If for some reason you wind up getting negative 7, that means you subtracted incorrectly. Do not subtract from 90, that's not one of the rules. And do not subtract from 270, that's also not a rule. The rules are, if your answer is already in the first quadrant, you leave it alone. If it's in the second quadrant, it's 180 minus the angle. If it's in the third quadrant, it's the angle minus 180. And if it's in the fourth quadrant, it's 360 minus the angle. So really, really be careful in how you're solving this. Alright, number 3, since it's negative, remember it says we're finding two angles coterminal that are between negative 360 and 360. This stems from the expression, the angle plus 360k. So I'm going to take this angle, add it to 360, and put any number I want in here. You could put any number. So I'm probably going to put a 2 for now. Whatever, put a 2. And then work it out. This gives me 61. That falls between negative 360 and 360, so that's good. Then I'll try again. Negative 659 plus 360 times, let's try 1 and see what happens. That's negative 299. That's between negative 360 and 360, so I'm done. Make sure that you follow the directions. Most of the time, coterminals don't ask for boundaries. But since this one did, make sure that your numbers are not too big and not too small. Alright, the next one, 999. I'm going to do 999 times 360 times, I'm going to put a negative 1 because I know that it has to fall between negative 360 and 360. If I put a positive 1, it's going to already be over 999. So I'm going to try negative 1 first. That gives me 639. That does not work. So I'm going to try negative 2. That gives me 279. That works. So now I need one more. So I'll do 999 plus 360 times negative 3. That's negative 81, and that also falls in between those negative 360 and 360. So that is how you do your coterminals. It's always the angle. The angle should be like this. The angle plus 360 times k. Okay, this says show all your work. So make sure that you show everything, and if it says draw a picture, draw a picture. So I'm going to draw a set of axes. And it says that the terminal side of an angle contains the point negative 510. So I'm going to go to negative 510, make a dot, and I'm going to draw a diagonal line through that dot. The initial side, I told you before, is always right on the x-axis. And then to make your right triangle, just come straight down and put your theta in between your initial and your terminal side. This is going to be negative 5. This is 10, which means we need to solve for r. The equation is x squared plus y squared equals r squared. Or you can use the other one, which is x squared plus y squared square root equals r. Two, both the same thing. I'm going to stay with this because it resembles Pythagorean theorem. So I have negative 5 squared in parentheses plus 10 squared equals r squared. 25 plus 100 equals r squared. 125 equals r squared. Take the square root. R equals the square root of 125. Now in the part 1 video, I told you about breaking down your square roots. 125, clearly, if you have $1.25, you know how many quarters that is, okay? Let's go back to the old school. We have a 25 cents, 25 cents, 25 cents, 25 cents, 25 cents, and 25 cents makes $1. Oops, that's $1.50. Let's erase that. There we go. So here is 5 quarters makes $1.25. So that means that I can probably divide 125 by 25. So when you divide 125 by 25, you're left with 1, 2, 3, 4, 5. Okay, remember the rule of breaking down means you should have one perfect square and one non-perfect square. And you will be allowed to use your calculator for this section. If you leave it like this, you will lose points because it's very obvious with the 5 and the 10 that this can be broken down some more. So this is 5 square root of 5. So the sign is going to be opposite over hypotenuse. And before I rationalize, I'm going to go right to my cosecant, which is hypotenuse over opposite. So of course, you can't have a rational in the bottom, so we're going to multiply both the top and bottom by square root of 5. That leaves us with 10 square root of 5 on the top, and 5 times 5, because remember this is 5, on the bottom. So we're left with 10 square root of 5 over 25. You know that can be reduced, because it's a fraction that can be reduced. So 10 over 25 is the same thing as 2 over 5. So this answer is 2 square root of 5 over 5. Okay, on this side, you can probably reduce it a little bit more. And you can reduce it by just saying that the top is equal to 1, and that's 2, so this is equal to square root of 5 over 2. So that's why you should break it down, because if you break it down, you get it to the more exact answer. If you leave it like this, you're not going to be able to have the exact answer, and it's just going to mess up your whole flow. Alright, the next one is cosine. Cosine is adjacent over hypotenuse. So before I even fix this, I'm going to go and do secant, which is hypotenuse over adjacent. Okay, once again, you cannot have radicals in the denominator, so I'm going to get rid of those radicals. And I'm left with negative 5 square root of 5 all over 5 times 5. Of course, that can be broken down some more to negative 5 square root of 5 over 25. Now you can reduce this fraction, and when you reduce it, this is 1, this is 5, so we're left with negative square root of 5 over 5. Now here, the 5's can just simply be canceled out. So you're left with negative square root of 5 for secant. Yeah, it's a lot of 5's going on. Alright, let me erase my quarters so I can write tangent. Tangent is simple. That's equal to opposite over adjacent. So that's 10 over negative 5, which is just simply equal to negative 2. Cotangent is negative 5 over 10, which reduces to negative 1/2. Okay, so our 6 answers are 2 radical 5 over 5, radical 5 over 2, negative radical 5 over 5, negative radical 5, negative 2, and negative 1/2. So ponder on this for a second before I erase it. Okay, the next one says that given that the terminal side of an angle lies in quadrant 2 and the secant of theta is equal to negative 11 over 3, find the value of the 5 remaining trigonometric functions at theta. Draw a picture. So you don't have to draw the axis for these types of questions. You just have to draw a right triangle. Secant is the opposite of cosine. So this will be negative 3 over 11. Now remember, cosine is equal to y over r. A radius can never be negative, so make sure that your negative sign goes with the 3. You have to give the negative to one of the numbers. Do not give the negative to both, because remember, a negative divided by a negative is a positive. So the negative should be assigned to one of the numbers. Okay, so imagine if we were going left. So I am going to kind of draw an axis, just so that I'm sure that I'm in the second quadrant. Okay, I didn't count left 11, left 3, up 11. We're just going to call this negative, left, whatever. So negative 3 is going to go here. 11 is going to go here because that's the radius. So now we need to find the value of sine, or of y. That's right. Cosine is x over r. Sorry. Okay, so we're going to do Pythagorean theorem, but instead we're going to use the x squared y squared formula. So x is equal to cosine plus y squared equals 11 squared. 9 plus y squared equals 121 minus 9. Y squared equals 112. Square root. y equals the square root of 112. Now, being that 112 is an even number, I'm going to see if I can divide it into my perfect squares. So when I divide 112 by 4, I get 28. I know I still can break down 28, so that's not going to work. When I do 112 divided by 16, I get 7. 7 can't be broken down. So when you break down 112, we have 16, perfect square. We have 7, non-perfect square, can't be broken down. Square root of 16 is 4. And square root of 7 stays the same. So make sure you do break it down. So that means that this answer that we're missing is 4 square root of 7. Notice how I kept it positive because we're in the second quadrant. And in the second quadrant, sign is positive. So now I'm going to go through all of them. Sign is going to be opposite over hypotenuse, meaning that cosecant is hypotenuse over opposite. As you can see, we have a radical 7 on the bottom. So I'm going to multiply both the top and the bottom by radical 7. That leaves me with 11 radical 7 over, remember that's 7, 4 times 7, which is 28. This cannot be broken down anymore, so it stays just like that. Okay, the next one is cosine. Cosine is adjacent over hypotenuse, and we had already found that earlier. And secant was the one that's given to you in the problem. Okay, last one to find is tangent. Tangent is opposite over adjacent. So 4 radical 7 over negative 3. And cotangent will be negative 3 over 4 radical 7. You do know you cannot have radicals, so we're going to multiply both the top and the bottom by radical 7. This becomes 7. 4 times 7 is 28. So cotangent's final answer is negative 3 radical 7 over 28. Please remember to break down. Break down. If it's possible to be broken down. Some of them can't. So what you do is you just keep dividing by perfect squares. If you don't know what a perfect square is, because that was 2 years ago, you can go to your agenda book and you'll see a row of numbers that are written like this. All of those numbers are called your perfect squares. Okay, so you would divide by these numbers and break it down. Okay, the next one says solve triangle ABC given that A equals 9, B equals 8, and C is a right angle. Round measures to the nearest tenth. Draw a picture. So, we are going to grade you on where you label your triangle. I'm not going to tell you how to draw the triangle and where to put A, B, and C, but you better make sure that that C is there and little c is there. Now, from this point, where you put A and B is totally up to you. I'm going to put B here and A here. You could have put B here and A there, it doesn't matter. As long as your little is across from your big. So once you label your triangle, you put in the things that were given to you. C is 90, we don't have to indicate that. A is 9, and B is 8, which means we need to do Pythagorean theorem to find C. Okay, so we do 8 squared plus 9 squared equals c squared. 64 plus 81 equals c squared. 145 equals c squared, square root of 145. C equals the square root of 145. These are where decimals are allowed, but you're probably not going to use the decimal too much. Okay, 145 does not go into any perfect square. It cannot be broken down, so pretty much you can keep your answer as the square root of 145. You can put this afterwards, but I really need to see this as your answer, not the decimal, because the decimal is an approximation. Alright, the next thing you should find are A and B. This is when you use your inverse. For A and B, do not use this because it's a decimal. Use these two numbers that are given to you. So for A, I'm going to do opposite over adjacent. That's tangent. So for A, I'm going to do the tangent of A equals 8 over 9. Of course, that means that I have to do the inverse tangent to get my answer for A. So A equals the inverse tangent of 8 over 9. So now in your calculator, put in inverse tangent 8 over 9. And you wind up getting that A is 41.6. Now you can do two things here. You can subtract this from 90, showing your work here, or you can just do the tangent again. I'd rather you do the tangent again because at least you know you're going to get the right answer. So B, I did opposite over adjacent. So for B, that's the tangent of B equals 9 over 8. It reverses. So tan to the negative 1 of 9 over 8 will give you the answer for B. So that means that B equals 48.4. Make sure that you are rounding properly. And you know, one of my pet peeves is when you forget your degrees. So don't forget your degrees. So how do I know I did this right? Because if I add 48.4 plus 41.6, I should get 90, and I do. If for some reason you don't get 90, you did something wrong. Alright, almost done. Okay, for the next one, it's the same idea, so I'm going to draw a triangle. Instead of this being an ABC triangle, this is a DEF triangle. So I will label F there because they said F is the right angle, and put little f there. As far as E and D, that doesn't matter where you put them, as long as your lowercase letter is across from the big letter. Alright, they told us that D equals 12 and E equals 38 degrees. Once you see degrees, that goes inside, and plus it's a capital letter. So now we need to find everything else. So we have D, E, F, D, E, and F. Now to get D, you can just do 90 minus 38, and that will give you the value for D. You could have also done SOHCAHTOA, and that would have helped as well. Alright, you could have also done SOHCAHTOA to check that you get 52, so we'll look at that later. Alright, so now I need to find E and I need to find F. So I can do SOHCAHTOA to find E and F. So E is opposite from 38 and adjacent to 38, so that's tangent. So this would be the tangent of 38 equals E over 12. You know that that means you have to multiply because the variable is in the numerator. So just do 12 times the tangent of 38, and you get 9.375, so that's 9.4. Alright, F, you could do Pythagorean theorem, but I would prefer that you don't, because your decimal might look different than mine. Because we rounded this, you're not going to have an exact answer. So I would rather you do SOHCAHTOA. If you do Pythagorean theorem, you're just going to wind up getting a different answer, and I might take a point off because you don't have the exact answer. So to find F, we can do adjacent over hypotenuse, and that's cosine. So notice that the variable is in the denominator, so we're going to wind up doing 12 divided by the cosine of 38. And that gives us 15.2. Now, if you wanted to check D to make sure that you pretty much have the right answer, but you don't have to, you can always just keep this. You could have done a SOHCAHTOA just to see. But since our answers here are in rounded decimals, it's best just to do 90 minus 38. It's the easiest thing to do. Alright. Okay, I think we got two more. Okay, the chairlift at a ski resort rises at an angle of 20.75 degrees and attains a vertical height of 1,200 feet. How far does the chairlift travel up the mountain? Okay, so if you don't know what a chairlift does, it's like there's this line when you're going skiing, and the chairs sit there, and then people sit with their skis hanging down. So that's how the chairlift works. Okay, this person just has... Maybe I should make the skis longer. Okay. So the chairlift rises at an angle of 20.7. That's an angle of elevation if we're talking about rising. So I'm going to draw my angle of elevation right here. And then it says that it attains a vertical height. So I mean, once you hit your highest point, that's your vertical height. And here's where I'm going to make my right angle of 1,200 feet. So vertically, if we were to travel vertically, this would be your 1,200 right here. So they said, how far does the chair travel up the mountain? So we're trying to figure out this area right here. Okay, so now we got to figure out SOHCAH or TOA. Well, 1,200 is opposite the 1,200, and x is automatically the hypotenuse, so that's sine. So it would be the sine of 20.75 equals 1,200 over x. You can do the switcheroo because the x is on the denominator. And now all you have to do is put it into your calculator to get the answer. And you wind up getting 3,387.0 feet. Okay, make sure you always round to the nearest tenth unless they ask you differently. Make sure that you draw a picture and make sure that you show all work. Okay, last question. A film crew in a helicopter records an overhead view of a skier's downhill run from where she gets off the chairlift. Okay, so we just solved, so these are two related questions. We just solved that the chairlift's distance to the vertical height is 3,387.0 feet. So if I'm going to draw this chairlift, I'm going to draw it again. Okay, and then they said the helicopter records an overhead view of a skier's downhill run from where she gets off the chairlift at the top, where she gets off the chairlift at the top to where she gets back on the chairlift for her next run. If the helicopter follows a level flight path, what is the length of that path? Okay, so if we're talking about the helicopters up here, okay, I cannot draw a helicopter. Okay, this is really bad, I'm sorry. So here's the helicopter, and it's flying above, and it's watching, and it's recording from where she gets off. So if you go up the chairlift, you're going to get off here. And remember, we already recorded all of this. So now she's going to ski downhill. Whee! So it's trying to record the path, the run from where she gets off. So this is where she gets off to where she gets back on the chairlift. So she gets off here, skis down, and or maybe she can go here, and then ski down this way, whee, and then get back on. So it looks like they're trying to figure out the distance from here to here. Because if she goes up the path, then she's going to come down, whee, back down here to go back onto the chairlift. So if normally she gets off here, let's imagine she's actually getting off here, and she gets on there. That's the level path, okay? So we know all of this information already. We could probably do SOHCAHTOA, or we could do Pythagorean theorem. So because we know this information, we could do SOHCAHTOA, we could do Pythagorean theorem, we'd get the same answer. So let's do Pythagorean theorem just to see. So Pythagorean theorem would say 1200 squared plus x squared equals 3,387 squared, because it has 0.0. Okay, let's work that out. Okay, so we're just going to subtract this on both sides. Take the square root. It's going to be a big old number. (3,167.3 feet). Okay, so that's what I got doing Pythagorean theorem. Now, if we decided that we wanted to do SOHCAHTOA, we could have said opposite over adjacent. So we could have said the tangent of 20.75 is equal to 1200 over x. So x equals 1200 over the tangent of 20.75. So x equals 3,167.3 feet. So we wind up getting the exact same answer doing SOHCAHTOA as we did with Pythagorean theorem. So for this particular question, you have two choices. Alright, so that ends your review for today. So hopefully that helped. My suggestion to you is to rewind, play it back, rewind, play it back if you don't understand. I'm going to attach a blank copy of the review. The time is now about 4 o'clock, so if you guys are going to be watching this within the next half hour, this gives you about at least 5 or 6 hours to review and watch. Okay? So good luck tomorrow. I'm really hoping that you all do much better than you did on the last quiz, because a lot of you need this test. Okay? So hopefully I will see some of you at lunch tomorrow. Alright, goodbye, good luck.